Hello everyone. Today, let's solve the problem number 287. Find the duplicate number. So you can just go through the question and you can just go through the example as well to understand the question properly. Let me summarize the question so that it will be easier to understand. So here we are given an array of integer nums. You can clearly see here we are given an integer array of integers nums containing n plus 1 integers, where each integer is in the range 1 comma n. That's what they have given here, 1 comma n, right? So this means that the array has n unique integers. You can clearly see array has n unique integers and one number that is repeated. Here you can clearly see 2, one number that is repeated. In this case 3, we have the 3. Here we can see here also this is 3 in the example 2 and 3. So what we need to do, we need to find the repeated number without modifying the array. So they have clearly mentioned we shouldn't modify the array. So we need to find the repeated number without modifying the array and also using the extra space beyond a constant amount, or by making use of only constant extra space. That's what they have given here. So I hope the question is completely clear. Then let's discuss the approach first, followed by discussing the edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. Initially, as usual, we'll discuss the approach. So let's discuss the approach step by step here. So let me come here, just give me a second. Let me give here approach. So we'll be making use of the Floyd's algorithm or Floyd's tortoise and hare algorithm. So we have already used this algorithm while we solved this one. I think detecting the cycle in the linked list. For that problem, we have already made use of this algorithm itself, right? So it will be easier to solve this one now. So when I say let's discuss the Floyd's algorithm first, what the how can we make use of it basically? So the array represents a linked list in our case. In the question they have clearly mentioned where each index points to the another index based on the value at the index, right? So we know this one. Due to the properties of the array, nothing but one duplicate it is present in the array. One duplicate is present in the array. They have clearly mentioned in the question. We know this one. Due to that property of the array, because one duplicate is found, a cycle must exist in the graph structure, right? So that is the reason we'll be making use of Floyd's tortoise and hare algorithm. We detect the cycle, right? Mainly to detect the cycle where we have detected the cycle, that will be basically this one, the duplicate number. Let's see that itself step by step. So let's come to the first step. So here let's see this one, approach. So first we will be having the 2 pointers. We'll be considering the 2 pointers. One is slow and one is fast here. So here we will set both both this one, slow and fast pointers, at the first element. Nothing but we can just give the index of the first element, nums of 0. Nothing but the element present at the first index. And then we will move slow at this one by one step. We'll be moving the slow by one step and we will be moving the fast by 2 steps until they meet at a certain point. This basically what it does, this detects the cycle, right? We have already discussed this one. Still, yeah, we know this one, right? And let's come to the second point. This is it for the first point. Then we have to reset one pointer. Nothing but let's reset slow here to the start of the array and keep the another pointer, nothing but fast, at the meeting point. So that's what we are doing in the second step. We have to reset one pointer, nothing but in this case we are resetting the start to the, we are resetting the slow to the start of the array, and we will keep the another pointer first at the meeting point. This is what we'll be doing in the second step. So let's move on with the third step. We are moving the both pointers fast and slow. So yeah, at one step at a time here. One step at a time. Why? Because the pointers where they meet again is the pointers where they meet is the duplicate number. That's what we need to find here. The pointers where they meet is duplicate number. Sorry, it has to be duplicate number. This is fine. So I hope this is the approach that we are going with. I hope the approach is completely clear, right? So next, let's discuss the edge cases one by one and then finally write the code. So let's discuss the first edge case, nothing but duplicates at the end. Let me consider the input here, nums, let me give here 1, 3, 4, duplicates at the end, right? Let me consider this one. The output will be 2 here. So we have the duplicate 2 here, right? You can clearly see. So the output will be 2 here. So the duplicate number is at the end of the array and the algorithm handles this one properly. So the output will be 2. This is for the edge case, duplicate at the end, right? Let's move on with the second edge case, nothing but duplicate in the middle. Let me give here nums 3, 1, 3, 4, 2. Here this one we have the duplicate in the middle, right? The same number 3. So the output will be 3 here. So here the duplicate appears in the middle of the array and the cycle detection works here, right? So the output will be 3 here. So this is for the condition duplicates in the middle. So let's move on with the third edge case now. So let's move on with third edge case, nothing but all the elements are same. Let me give the input here. All elements are same here, right? So let me consider this input. So here the output will be 3. Sorry. Yeah, here the output will be 3. Ignore this. So here all the values are duplicates, right? So the output will be 3 here. This is for the condition all the elements are or all elements are the same. This is fine. Let's move on with the fourth edge case. Nothing but large array with duplicates. So I'll just consider the input here for the large array. So I'll just consider here 1, 2, 3, 4, 5, 5. You can still consider the larger array. I'll just stop it here. So we have the duplicate here, right? For this 5, we have the duplicate at the end. Nothing but the large array with duplicate here. So the output will be 5 here. So here the algorithm handles the large arrays where the duplicate appears at the end. Let's move on with the final edge case or the fifth edge case, smallest input size. When I say smallest input size, at least we should have the two numbers, right? One the number and another one the duplicate. So let me go here with 1, 1. So here this is for the smallest possible array size, right? So the output will be 1 here. So what happened to this one? Just give me a second here. Output will be 1 here. This is for smallest input size. So these are the 5 edge cases that we need to keep in mind. The first one is for duplicate at the end, and the second one is for the duplicates in the middle, and the third one is for all elements are the same, and the fourth one is for this one is for large array with duplicates. So I forgot to write here, I think. So this is for large array with duplicates, and the final one is for the smallest input size. These 5 edge cases we need to keep in mind. I hope all the edge cases are clear. Next, let's start writing the code and then finally discuss the this one complexities of the code that we have written. So here, as we had discussed in the approach, let's initialize 2 pointers, nothing but slow and fast here. Let me give you, let's slow. We are initializing both at the starting index, right? Let's slow equals nums of 0. Also, fast equals nums of 0. This is fine. Slow and fast pointers both start at the first element. That's what we are doing here. Next step is we have to detect the cycle in the linked list. So let's make use of the do while. I haven't used do while in a while actually. So let's make use of the do while for this problem. So I'll just go with do. So slow equals nums of slow. What we are doing here, we are just moving the slow pointer by one step and we have to move the fast pointer by two steps. That's what we had discussed in the approach, right? So just let's move the slow pointer by one step here, nums of slow, and let's move next, in the next step, let's move the fast pointer by two steps. I can just give in this way. Fast equals nums of, here nums of fast. This is fine, I think. So let me make use of while here. We are making use of the do while loop, right? So while, in while what we have to give, we have to loop until slow and the fast meet. So until the cycle is detected, right? We have to keep, we have to loop until slow and fast meet. So how can I write? I'll just give here while condition is slow not equal to fast. This is fine, I think. I hope this is clear. The next step is, let's move on with the next step. Nothing but we have to find the start of the cycle. Nothing but we have to find the duplicate number, right? Let me initialize here. Slow equals nums of 0. Nothing but we have to reset the slow pointer to the start of the array. So that's what we are doing here. We have to continue until the slow and the fast pointer meet again to detect the duplicate number. That's what we had discussed in the approach. So I can just write or articulate this one in the form of code like this. I can give slow not equal to fast here. This is one thing. And within this, we have to move the slow pointer by one step and we have to move the fast pointer by one step. So this is what we had discussed in the this one, right? Approach, right? So how can I write this one in the form of code? We have to move the slow pointer and fast pointer by one step. This one will be nums of slow. This one for the fast, same thing, nums of fast here. I hope this is clear. Finally, what I'll do, we have to just give me a second here. We have to return the point where the both pointers meet here, slow and fast, right? This one, we have to return the point where both pointers meet. That is what is the duplicate number. In this case, it is slow. So let's return the slow here. So this is it. Let me format this one once and hit the run button. So you can clearly see here the sample test cases are getting passed here. Let me hit the submit button. So you can clearly see here all the test cases are getting accepted. So the code works absolutely correct here. So let's quickly discuss the complexities of the code that we have written. So the approach that we went with here is, we know the Floyd's cycle detection algorithm. And what will be the time complexity here? Overall time complexity would be big O of n. Why? Because we are traversing the array at most twice here. We are traversing the array at most twice here. You can clearly see here. We are traversing the array at most twice. So the overall time complexity would be here big O of n, right? And what will be the overall space complexity here, or the space complexity? The space complexity would be big O of 1 here. Why? Because we are making use of only the constant space. We are considering only pointers, 2 pointers here, right? One is slow and one is fast. So overall space complexity here would be big O of 1. Right? I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.